So last week, 3 weeks ago, we did visualizing data, so how to do plots and various things like that. Let's go back, okay? And the start, we had all the sort of basic mathematical commands. Today, we're actually going to move on to things called script files and functions. So this is where we're sort of building upon what we've learned about Matlab already to make sort of essentially programs, okay? So there's a bit more programming is the way we need to start thinking about this, okay? You store those programs in script files, or if you're or a particular type of script file called a function, okay? So that's what we're going to cover today. So I'll start off with a little bit of an introduction, talk about script files. I'll do some demonstrations using Matlab, okay? And then we'll move on to sort of these things called conditional statements, which use relational and logical operations. And that's the whole sort of if such a condition is met, then you do this, okay? So it's starting to look at how do you manipulate, how do you run through the program, how does the program make decisions? That's on this part here. Okay, so let's start with the basic script files. Up until now, you've been entering commands in the command window. Yep, okay? So you've got your command prompt, you enter a command, press return, and the program does the command for you. Now, that's okay, but it can become cumbersome. Say you've got a long list of things you're doing in a sequence of commands you're running, okay, and you get to the end, say it's plotting a graph, and you decide, oh, in fact, I want to plot a different range of values, okay? So you've got to go back, you've got to redefine your, say, x coordinate, okay, then go through all those same commands again, exactly the same, just to move the range of values. That's quite cumbersome. You've got to do the stuff twice. Well, script files enable you to save all those commands in a script, okay, and rerun it as many times as you want, just changing one thing. And we'll go through a demonstration of that. Script files are essentially plain text files. You don't need to use Matlab to edit them, but obviously it helps if you do, because Matlab will color code all the commands to make it easier to read. Okay? It contains a series of commands, just like the command prompt, except for you just write them as you want to, okay? And they're executed like a program. Okay, so like I said, this is starting to move on to actually programming using Matlab as opposed to just using it as a big calculator. Okay? There's also a thing called a function file, which is a particular type of script file. Okay? You've already used functions in Matlab, like things like square root, sqrt, open bracket, you enter the number. That's a function. Well, one of the powerful features of Matlab is you can make your own functions. Okay? And we're going to go through how you do that as well. So it's a special script file, and basically you can make custom functions to do anything that you want. So say you had a particular type of, for example, say you're doing a big report and you want all your figures to look the same, okay? Well, you actually make a function that will do all the plotting and have all the commands, so that make the figures look identical to each other. That could be a function, say, my plots, okay? And you enter your x and y coordinates, and it'll do everything around the figure for you, okay? That's one example of a function file. But like I said, we're going to also go through an example of that. So let's move over to Matlab. Let's get these slides out. Okay. So here I am in Matlab. I'm just going to go to my stick because yeah, here we go. Because I've got some files on here. Right, so in Matlab, to make a new script file, you can click on the new file up here. Okay, and what comes up is a text editor window essentially, and this is where you enter your commands. So I could just do 2 plus 3. X equals or Z equals 2 plus 3. Okay, so there's my command, and if I press go, run, which is obviously this button, okay, save and run. It'll ask me to save it. I'll save it. I'll just call it example. Okay, notice that script files have an M extension. Okay, when somebody says, have you got the M file for that, they're referring to a Matlab script file. Okay, so I'll save it. Okay, so it's run, and you can see it's run a command called X, which is the name of my file here, and it's given me my output Z equals 5. Okay, that's a basic example. Now what I've got here is the first one in your notes. Okay, this is called sinewaves.m, and we're going to go through. I'm going to describe going through before we run it. Okay, this is actually going to plot the graph that you saw in the last lecture, the sine waves. I don't know whether you remember. There were 3 sine waves plotted to show you some of the capabilities. But this file is going to do that. Okay. Now there's a few parts to a script file that you should always have. It's not 100% necessary, but it's really good practice. Okay, and you should really do it so that when you're referring to them, you can understand what you're doing. Okay. First off, the title. That's the file name. Okay, and I say what the file is aiming to do. Okay. I then stick the author in. Okay, last update 17th of July is when I wrote this. Okay. And then I include this thing called the variable dictionary. I don't know why it keeps running it, but I shan't point at it. I'll point at it with the mouse. Got the variable dictionary, okay? And these in here is where I stick the variables that I use in my file, okay? So I use the variable t for my independent variable. That's my x-axis. Okay, and then I use y1, y2, and y3 as my dependent variables. Those are the things that vary dependent upon t. Okay? Now, these things are all comments, okay? You can tell they're comments because they're green, but to make a comment, you start off your line with a % sign, okay? So anything following a % sign, Matlab will ignore when it's running it. It's a comment so you can read this file and know what's going on, okay? So that's how I can write all this sort of stuff, and Matlab, like I said, when it actually runs it, it ignores anything with a % sign. Okay, anything after a % sign will be ignored. So I've got these commands down here, clear all, CLC and close all. Or clear all will clear all my variables, okay? And I've said that there. So notice I write % sign and then I can write a comment so I know what this is doing. CLC clears the command window. You've seen all these before. And close all will close all the previous figure windows that are open, okay? Because I don't want to confuse myself with hundreds of figure windows. Some of you may have come across that already. Okay, if you keep doing plots and new plots, it keeps creating new figure windows, and you've got to keep closing them yourself. Close all will do that for you, and it'll just produce the figure windows that are asked for in the command. Okay. Next, I define my range for t, which is my independent variable, and then I calculate y1 and y2 and y3, as we saw in the last lecture. So this is some sine waves with different starting points. Okay. And then I plot them. You've seen all these commands before. Plot t, y1, okay, and that's going to be a dot dash line in red with stars at the data points. I've then held the graph on, okay, so that locks whatever's on there, and then I can plot the other things on top of that, okay, y2 and y3, and then I've used different commands here. And then at the end I've got labels and a legend for the graph, okay. And so you saw as I ran it, okay, Matlab produces this, which is what we were looking for. Okay. Now you may recognise that from 3 weeks ago. Okay, that's one of the things we did. Let's say I wanted to change the range. Okay, well if I was doing it command line by line, I'd have to go back all the way up these commands to this one here. Okay. Now let's say I want to do it from 0 to 4 pi. Well, I can change that there to 4, and I just press run again, and I get from 0 to 4 pi. So notice how much time I've saved by just changing, by using a script file, okay? Script files might take a little while to write the first time round, okay? But the moment it makes sense to use a script file is when you make the first change. It's like using CAD. CAD can take an awful long time when you just want to draw something quite simple. But the moment you make the first change, you don't have to erase it all and draw it again from the start. You can just make that one small change and it'll update everything else, okay? With respect to that change. So it's, like I said, it's a real boon to use script files when you're doing relatively complex things. And this is quite a simple thing, you think, yeah, okay? Just printing or plotting some data points, okay? Well, like I said, I've made a small change very early on, and it's changed the whole thing, okay? Which is what we're looking for. So like I said, to run a command, you can press this go button here, okay? That saves the file and then runs it, okay? That button has a shortcut, F5, so I can press F5 and it'll do it, okay? there's a few other, there's I think under debug, you can press run sine waves.m, okay? And the other way to do it is if you're in the command window of Matlab, so let me go back here, I could just type in here, sine waves. If that file is in the directory, it will run the file, okay? And it's done that there, okay? Now obviously that's quite useful. If you, let's say you're running a script file and you want to call a file that's within that script file, you can obviously enter that into that script file, okay? So that's quite useful to see. Okay, so that's basically script files. Are there any questions on them so far? Okay, do you understand all the lines of the code in this file? Okay, this is on page 46. This is on page 46 in your notes. Okay, and you can read it there. These script files that I'm using in this lecture are going to be uploaded onto Blackboard as well, so you can download them and have a look at them yourself if you wish to. Now, one of the other things that are quite useful commands to know when you're dealing with script files are these commands called input and disp. Okay, and if I type in input, well, I'll say x equals input, and then I'm going to ask, let's say, enter a number between 1 and 10. Okay, so that's input. I've opened brackets. I put whatever I want to say in quotes. Okay, and I've assigned whatever is input into x. And you can see what happens when I press return. Matlab asks me enter a number between 1 and 10, and it's expecting an answer. So if I put in 6, it assigns 6x to 6. Okay, so this is a way of making programs sort of quite interactive. Okay, you could set up a script file to say, ask me to enter a number, x equals 6, and between 1 and 10, you enter 6, and it will obviously save that in your program. Okay, the other one is disp. Okay, so if I, my name is Ben, Matlab will say my name is Ben. Okay, so whatever you type in the quotes will be given there. The other one you'll see is called error. Okay, and you'll see it in. And what that does is, if it's in a script, okay, if it's in a script, it'll display it in red and stop the script from running any further. Okay, so say, it's one way of error checking is if you've asked for a number between 1 and 10, okay, and the number you enter is say 11 or whatever, okay, you can set it to say an error occurred, you entered the wrong value. Okay, so that's input and disp. And what we'll do is we'll make a very small M file to do that. I'm not going to bother doing all the comments and stuff because this is just a very basic example, but what I can do, in fact, I'll just change that example in here. Let's close that one down. So I'm just going to say input, okay, enter a number between 1 and 10. Okay, and we're going to say x equals that. Okay, and then I'm going to say disp, the number you entered was, okay, and then I wanted to say what x is. Okay, now you think, well, perhaps I can put x in there, okay, but you can't. The reason for that is that x is a number, and the bit of text that disp is showing is what's called a string. Okay, you may have come across strings in programming before. Okay, or a string is a bit of text. Okay, so you need to convert the number to a string, and there's a very useful command in Matlab, num to string. Okay, and then I put x in brackets. Okay. And for the disp to show it, I need to put all of this in square brackets. Okay, this is the examples in the notes. So if I save that now and run it, okay, Matlab's asked me, enter a number between 1 and 10. I enter 6. Yep, 6. Okay, the number you entered was 6. So a nice bit of easy programming to make the program interactive. Okay. So that's a bit of interactive stuff that you can enter into programs. I'll show you an example of that in a minute, okay, when we get on to conditional statements, but that's an idea of what's going on. Now, function files. So if I clear the screen, to get a new function file, you can either start from scratch by entering a new command window like this, okay, but there is actually quite a nice little command. I close that down. Go File, New, Function. It sort of pre-fills in some of the things that make M file a function file. Okay, they always start with function. Okay, that command, and then there's various bits of information that you fill in. Okay. Output args, okay, that's arguments, is what it means by args, is what the function returns when you run it. So, for example, the square root function, the output argument will be the square root of the number you entered as the input, okay? So that's, here it's output args, arguments, okay? Untitled for will be the name of the function file, okay? So, you'll see that in a second. And then the input arguments is what you give to the function to get for the function to run. Okay, so for example, with the square root, you input the number you want to square root. Square root 64, 64 is your input, the output will be 8, okay? 8 times 8 being 64. So with the square root function, that bit would be square root, sqrt. Okay, input arguments, I don't know, you can just call it number. Output arguments will be the square root of that thing, okay? But since square root is already done, we don't need to worry about that. Now what I've got here is I've actually written a bit of Blue Peter moment. I've actually come with a function that I've already written, okay? So here's a function. You can see the output is cylinder or silvol, okay? Because this function, as you can see in the description, calculates the volume of cylinder with diameter d and a height h, okay? And the name of the function file is called calcvol, okay? That's something I came up with. Okay, and you can see that the two inputs I've got is diameter and height. Okay. So what happens when I run this function is it will assign the variables that I enter as the input volumes to variable names diameter and height. Now those variables are internal to the function. Okay, and I'll demonstrate that in a second. They're only contained within the function. Okay, so what it does, it runs the command. I've got obviously my name, and when I wrote it 2 days later on the 19th of July. And then I've got my variable dictionary. And you can see I've got diameter, height, CS area and cylinder volume as various things that I use in the command. Okay, and you can see what I've done. CS area, okay, so cross-sectional area is obviously pi d squared upon 4, okay, or pi r squared, depends on how you want to think of it. Calculates the cross-sectional area of the cylinder, okay. And then cylinder volume is obviously that cross-sectional area times by the height. That calculates the volume. Okay, and then obviously you've got an end at the end. So if I run this command, so go to Matlab, this one, I'm in the same directory where calcvol is, and I could say calcvol, okay, and I enter. Let's say I've got a diameter of 3 and a height of 5, say, meters, okay? Well, I enter those things because that's what the command is asking for, and it gives me my answer of 35.3429. Now, if I clear all the variables are gone, you can see I can run that command again. Notice the only thing I've got at the end is answer, okay? Those variables that I used, height and diameter, all that sort of stuff, they're internal to the function, so they're not saved in your workspace. The function just sits there and operates them irrespective of what's going on in your workspace. Okay. Now you use functions generally when you've got a specific task you want to do. Like I said, plotting figures to be exactly the same thing. All the variables associated with those figures, you don't need to worry about things like axes, labels, and that sort of stuff. If you want your figures to all be the same, that doesn't matter. You don't need to save them in your workspace, but you do want it to use variables in terms of the way it operates. Okay. So that's an example of a function file. So it goes off, performs the calculations with those input arguments, and then returns whatever you throw. Obviously, I could actually write cylinder volume equals calc vol 3.5, okay, and that will obviously give me assign a variable called cylinder volume. And if I wanted to change those numbers, I could just obviously change these numbers in here. Okay, so it's, I've created a function that will calculate the variable, the volume of a cylinder. Okay, so any questions on that? So this is functions are a specific type of M file, okay, specific type of script file that will go off and generate, you use them to generate some sort of answer, okay, that you want, as to fulfill a specific task, okay. And one of the examples in the exercises that you've got to do, number 2, okay, question 2 in the worksheet. I've asked you to create a function that will convert feet into meters, like a little conversion program, okay? So say you were working with the Americans, okay, and they were working in inches and you were working in centimeters, and you were always having to convert between one and the other, okay? You could create a little function file that will do that conversion for you, okay? So that's one example. And if you were using that function file, did you hear about that Mars aircraft that was going to go to Mars and it crashed? Because the Americans were using inches and we were using meters or whatever, okay, and it didn't, it obviously crashed because nobody had bothered doing the conversion. If they used a function file, they might have been able to spot that. Okay, so that's function files. Now we can move on to conditional statements. So let's go back to the presentation. So like I said, anything that I've used in the program of my pre-made documents, okay, you can download them from Matlab to have a look yourself, okay. And again, in the worksheet, some of the programs, okay, I've asked you to write a script file, okay. The way I'm going to give the answers to you, as before, where I just, the answers were just the commands you needed to enter. Here, I'm actually going to give you the answer file, sort of the program file for you to have a look at. But I want you to have a go at them before you get the answer file, so I'm not going to upload them just yet. Okay, so you can have a go, and then if you save them, obviously you will have to save them to run them. If you save them on a stick or something, you can check your answers compared to what I've written in the way of answering it. Okay, so conditional statements. Up until now, the way you've written script commands and the way you've run Matlab is just commands in a line, and Matlab will just run through them one by one, running those commands, okay, as you enter them, or as it comes across them in a script file. But there are ways for Matlab to do various things, to skip files, or skip commands, if certain conditions aren't met, okay, or to run commands only if certain conditions are met. And that's what's all known about conditional statements. The next session, okay, in 3 weeks' time, we're going to look at loops, okay, a way of Matlab to actually repeat commands for changing values, okay, and we'll talk about that in the next few weeks, okay. But this week we're just going to talk about conditional statements. Like I said, so conditional statements essentially is going to follow this if-then process. If a certain condition is met, then you do that, okay. So if x equals 10, then you can say that x equals 10 or something like that. There's all sorts of different things to do. So it only does those tasks if a certain condition is met, okay, and it allows for decision making in Matlab. Okay, that's essentially what's going on. Now there's various things you have to bear in mind when you're using conditional statements. There's 2 things you need to know, and I've got the tables in the notes. Okay. There's this thing called relational operators, and that's used to compare values with each other, okay? So obviously you can say if x equals 10 or whatever, then you use the Matlab symbol of 2 equal signs, okay? Not equal, obviously, you enter tilde equal sign. Greater than is obviously the greater than sign. Less than is the less than sign. But then greater than or equal to, you write greater than and then equals. Less than or equal to, less than or equals. Okay, so these are the basic relational operators. Okay, and the way they work is if the thing is true, if that condition is true, it returns 1. Okay, and if it's false, it returns 0. So let's go through an example. Okay, if I go back to the command window in Matlab, where is it? There it is. Okay, so I'm going to clear the screen. So if I say a equals 10, okay. I'm going to say b equals 5. And if I say, well, is b less than 5? No. let's try A, sorry. Okay, my answer is 0, because obviously B is 5 and A is 10. So B isn't less than 5, so it says that's true. If I change it around to is B less than 5, I get an answer of 1. Okay. Now if I said x is 7, okay, I can see it is x less than 5. Sorry, x less than B. Okay, obviously no, it's greater than B. Okay, is it less than A? Yes, it is less than A, so it's got to be between the two. Okay, so that's how you sort of, those relational operators work. So that's relatively straightforward to understand. Okay. Does A equal B? No. Now notice, if I wrote A equals B, that does something else. That reassigns A to the value of B. Whereas here, it's checking to see whether they equal each other. Okay, so there's an important difference. Now I've reassigned A to be B. Okay, so A's got the value of 5. Now if I run that A equals B, they've got the same value. So obviously the answer is 1. Okay, 1 is true, 0 is false. Now the other type of operator that's useful is these things called logical operators, okay, which are used to combine, okay, those relational operators, to be used in combination with logical operators. Obviously that should be relational up there, apologies. Okay. So let's think, for example, you can say x is greater than A and less than B, okay. So x is obviously between A and B. That's sort of mathematically how you'd write it. And these logical operators, they're called Boolean operators. Okay, and the three main ones are and, or, and not. Okay, so if x is greater than A and less than B, then you can run a certain command. Okay, or you can say x is greater than A or less than B, you can run another command. Or you can say x is greater than A but not less than B. Okay, so you can, like I said, you can combine these things together and you can get certain things to happen. For the nerds among you, you might have remembered that on Friday, the 2nd of November, 197 years ago, a chap called George Boole was born, okay, and he's the guy that came up with all this sort of logical algebra, okay, which is what we're using here, okay. So for example, let's say I wanted to do x is greater than A and less than B. So I want x to be between A and B. Then you write this. X is greater than A, okay, and x is less than B. You don't write it the way you write it mathematically. A is less than x, which is less than B. Okay, you've got to use it in this sort of way. So you have one condition, some operator, logical operator. Here I'm using and then I have some other condition. Okay. And so if I go back to my command window, let's set A to be 10 again, and B to be 5 again. Okay, I'm going to set X to be 4. Okay, so if I say, no, I'll set X to be 7 again. Okay. So if I could run certain commands, I can see whether A is greater than B. Okay, yes it is. So obviously B is not greater than A. Okay, I can see whether x is greater than b. It is. Okay, and I can combine the things together. I can say, well, okay, if x is greater than b, okay, and x is less than a, then what's it going to come up with return? It's going to return 1, because that's essentially done this whole, b is less than x, which is less than a. Okay. That's doing that command, okay? If I did that, b is less than x, which is less than a. Okay, well, in fact, it does work. It didn't used to work. That's obviously something they've added, okay? I'm sure that didn't used to work, because I remember coming across that when I was doing some programming in Matlab, but obviously this is a later version, and they've implemented that, which makes sense. Anyway, so yeah, you can use logical operators to do that, and I've got... Now the other thing you can do with these logical operators, you can use them with vectors, and it will compare two vectors together. So I've got an example in the notes. So vector 1, 5, 3 and 7. Okay, and I've got y equaling 0, 2, 8 and 7. Okay, so there's my two vectors, x and y. And I can say k equals x is greater than y. And what this does is it looks at the values in the vectors and we'll compare them sort of element by element to see whether x is less than y. So what's the first case? What's this value going to be when it compares x and y? If x is less than y, it's going to be 0. Here, x is less than y, 0. X is less than y, 1. X is less than y, 0. Exactly. So if I run that command, I should end up with a vector 0, 0, 1, 0. Exactly. So you all know this stuff already. It's obviously far too easy. If I could do obviously k, x equaling y. Obviously the only values that are equal to each other are 7 and 7. So that's obviously you get 0, 0, 0, 1 and so on. Okay. And you can do it with logical operators. I've got this one. K equals x is less than y. Okay. Or x is greater than 4. And then with 1, 1, 0, 1. Okay? So this is saying that if x is greater than y, then you give it a 1. Or if x is greater than 4, then you give it a 1. Okay? So here, obviously, I've got x is greater than y, x is greater than y. This is also greater than 4. Okay? Here, it's less than y, so that doesn't fail. And here, it's equal to y, but it's greater than 4, so I get a 1 there as well. Okay, so that's sort of combining those operators together. So, what's the use of looking at all these things? Well, it means we can use what's known as the if-else construction in Matlab. Okay, and basically the way it works is let's go for x equals 5 and y equals 10. I can write if in Matlab. Okay, let's clear the x, y, so we can see what we're going. I can write if x is less than if x is less than y. No, yes, it is. Okay. Then you do a certain command. Okay, so I can say disp. Woohoo. Okay, enter that command. End. Okay, so if I no, I need to. Sorry, I need to enter that into script, don't I? Silly. Copy. So if I go back to that example script, if I run that, go to Matlab. Oops, the Matlab. Where is it? X is greater than y. Oh, well, that's not true. So if I go, if I set x to be 12, okay, then run ex again, I get woohoo. Okay, so you can see that's what's going on. That's why it didn't reply woohoo then, okay, because it wasn't true. Okay, so you can enter these things in the command window. Makes a lot more sense if you enter them into script files. Okay, now I've got another example here, simple if script 1. And what this is doing is asking me to enter a number, and it's checking to see whether x is greater than 10. And if it is, then it's going to say the number you entered is greater than 10. Let's run it. Enter a number, 1. Obviously, it meant that that command wasn't actually run, because that condition wasn't met. If I go back to the thing, I entered 1. It said if x is greater than 10, okay, well it wasn't. So it just went straight to end. It skipped that command. You can see the idea behind sort of decision making in Matlab. Now if I run the command again, okay, simple, let's just run it, just double click on it, run it again. Okay, if I enter 15, now obviously runs that command because 15 is greater than 10. The number you entered is greater than 10. Okay, I've got a slightly more complicated one, but it's still very simple. This time it's going to do a few things. I enter a number, okay, if x is less than 0 is the first thing it does, and if it is less than 0 it displays the number you entered is negative. okay, which obviously makes sense. Okay. If that thing isn't met, it then goes to the next one, next if statement, else if. Okay. So if that wasn't met, it runs to else if and says is x less than 100. Okay. And then if that is true, then it says the number you entered is greater than or equal to 0 and less than 100. So why would that command not run if I entered a negative number? Because surely a negative number is less than 100 as well. Any ideas?
At that point.
Yeah, exactly. If x is a negative number, it runs the number you entered is negative and then goes to end. Okay, so it skips everything else because you've already met one of the conditions. So we can automatically count out all the negative numbers if we want this command to run. Okay, so the way we've constructed it. If x is greater than 100, then obviously it skips that one and comes to this one. And else without the if means that any other numbers that we enter will run this command. Okay? So I don't need to put else if x is greater than 100. Okay? Or x is greater than or equal to 100. I don't need to say that because any other number I enter will satisfy that command. So let's run this program. We can try a few values. Okay, -5. The number you entered is negative. Okay, that makes sense. What about if I do 0? The number you entered is greater than or equal to 0, and if you can see the screen, and less than 100. What about 2? I get the same answer. Okay, greater than or equal to 0 and less than 100. Let's try 100. It's greater than or equal to. So you can see what's happening in Matlab is it's running those values, checking what those values are, and it will return those display commands. Okay. Now you can use if statements to do an awful lot more complicated things. Okay, and you'll come across them later on. Okay, and certainly in your assignment, you'll obviously have to do that sort of stuff. So that's essentially what we're doing today. Okay, that's more or less it in terms of the stuff. But hold on, don't leave yet. I've got something else to show you. So like I said, we've got week 17. In 2 weeks' time, you've got an assignment that's coming out. You'll be able to download it, and you can use the sessions between then and Christmas to ask us questions on that.